All right, so we are recording, and so anyone who have missed the session, they can view the recording. So um, feel free to view the recording. I'll upload it on YouTube, and there will be um, chapters dedicated. So the if you just want to skip to the actual like GCCP Quest stuff, so you can skip to that. So let's start. We'll give you a heads-on like a introduction a bit. We had an intro session, but not a lot of people could join it at that time. So I'll be condensing both the intro and the quest one in this one. Um, is the screen visible? I'm seeing like the screen is going down a bit each time. All right. So we are going to learn the Google Cloud with the cloud engineering pathway. So Google Cloud is offering us this path basically. Let's see it here. This path, cloud engineering learning path, as you can see, and this path consists of total 13 learning activities. First will be an intro lab, and there will be eight courses, I believe. Yeah. So all the participants are requested that you could go through this course. These are like actual like Coursera courses. So like if you go on Coursera, you can actually view each of them, and but here they are providing it you for free, so you can go through these courses, and after you like go through these courses, you will get this completion badge, which you can actually like put up on your LinkedIn. And there are like sort of time gaps given, like this can be done in like 5 days, so you can go through. There are a lot of video contents, there is a document content, there are quizzes. I will not help you through these ones, because you know these are like not very interactive ones. These are you just watch these, and as you go. So they are of those type. I will be guiding you towards this intro lab today, and this quest 1, hopefully, if we can in the time limit. And I'll explain you each step instead of like these quests itself. So it is like a roadmap thing, and why do we do this cloud engineering learning path? It's to look ahead to this Google Cloud Associate Engineering certification. So if you're not aware about certifications, there are a lot of like certifications. If you can actually search certification, so there are certifications are different from certificates. Certification is to get a certification like this cloud associate engineer. You have to give a certification exam, and after this you will get this certification for 3 years after from the date of certification. And a lot of companies and have these as their like requirements, or like a good to have on their job postings. So there's a lot of advantage of getting a certification. So essentially this entire path of cloud engineering learning path, it trains you to get those cloud skills. So GCCP is that campaign. A lot of people are in the lobby. Okay. So that's all. Like you can. So I'll be guiding you towards these quests. So if you can, if you have a Chrome browser, then you need. So basically, like what I was saying is, the Google Cloud Engineering Learning Path. This is a path designed by like for Google Cloud Skill Boost, and it is to set you up for once you complete the path, you can check out for certification exam, which is the Google Cloud Associate Cloud Engineering certification. It's a mouthful. So this is the certification. Like once you get this, you have this exam examines these abilities of yours, and once you get this certification, it basically assures any sort of like job recruiter or anyone who are looking for a cloud engineer. So they'll be assured with if you have this certification. A lot of job postings have these certification as a like a mandatory or like a good to have. So when you get the certification, it will be available for 3 years, and it's a very nice good to have initiative by Google. And through GCCP we are actually getting access to Google Cloud's the Skill Boost program. So this Skill Boost program has a lot of paths. If you might have like seen, in past sort of campaigns, they were focusing on this one. They're focusing on, I guess, data engineering learning path, but this time we are focused on cloud engineering learning path. So we'll be doing these. There are 13 activities, and one is a introductory lab which we'll be doing today, and one is quests, and these quests will be followed up in the next sessions. And these courses are, I'm expecting like you guys can go through these courses. These are basically like Coursera type courses. If we check them out, there are like video lectures, there are documents you can read through, and there will be like quizzes on the stuff that you've learned. So I will not be covering these. These are very passive, and these are very like active sort of thing that you have to do. So I'll explain you throughout. There will be like recordings provided as well if you are like not having a good sustainable like network right now. These are the points to note. These sessions would not cover the courses, only guiding through the quests. Participants are expected to go through the courses themselves. If any personal doubt or problem while solving the quest, they will be addressed in the doubt solving sessions, or you can also reach out to me via WhatsApp. Queries can be raised about the session when prompted or at the end of the session. Okay. Any queries now until now? I'll be allowing you guys to unmute yourself. So first you'd open up your browser. You'll open up a incognito tab. Why incognito tab? Because you don't want these to get saved. So let's see, incognito tab, go to this link, incognito tab, because we don't wish to save all of these activities, as in like whenever you're signing up that you so there are two types of Google Cloud. I'll make up their distinction. Google Cloud, okay, google.com, Google Cloud. Okay, so there is this Google Cloud, which is only for like people who actually wish to like use Google Cloud. And there is this Skill Boost thing, which is an initiative by Google to train people into like using the cloud, but not essentially like paying it for a price. So any sort of like organization who wishes to use Google Cloud, any sort of startup that is coming up, which want to like have their project, they want it on the cloud, they want it to be hosted, but they don't necessarily so they can use the cloud, and they can use it in as a pay as you go. I'm hoping that you guys are have clicked on the path and have gone through like incognito and have signed in just like me. So I'll say it again. Go to incognito mode, open up a Chrome browser, all right. So once you log in, it should look like this. Let's go through the intro lab. I'll also enable my webcam, so give me a chance. Connect. Hey there everyone, I hope like my face cam is also visible. Let's adjust this a bit. Flip it, and okay, I will also remove that. Let's go through the first introductory lab. I hope like you guys have also gone through incognito tab and logged in by your Skill Boost account, and now we are going to go through the tour of the introductory lab. Okay, so we'll be going through the first introductory lab. Let's go. So this lab is basically, it teaches you how the next few quests are going to be. It gives you like an introduction to all of them. So let's understand here. So I've told you the separation between like actual Google Cloud users and us. We are in the GCCP program, and we will be given the opportunity to learn through cloud without necessarily paying for it. So you might have seen the sort of monthly subscription thing. So monthly subscription, basically we have a whole month, like from November 14 to December 14, to access Google's this lab environments and everything. So these are self-paced labs, and we can learn through them, and these are very like sort of interactive as well, but you can read through all of this. These are basically like documentations, so everything is mentioned here. So start lab, we have started our lab. Let's open Google Console. So opening Google Console, so I'd suggest like you do these like one tab here, one tab here, so you can read and also do them at the same time. You can copy your username, copy and paste it here. These emails and passwords, these are very these generate on a like a fixed period of time, and these accounts will then get closed. So we are having a limited access to these, and yeah, obviously like if you use it on your like browser, when you log into something, it will get saved, right? So we don't want that. So it will essentially clog your entire Google whenever you sign in. Okay, password, I'll enter the password. Okay, so and you're agreeing to all the terms and conditions by Google. So basically all of your services, all of the activities that you're doing on this sort of new lab that is generated now, it will be monitored, and uh, basically telling you that you don't owe Google, so they can actually like terminate your account if you use more than the resources that is like allocated for you. So here we have to make a virtual machine, right? So it would be pretty like not they will restrict your account if you use like to make like Kubernetes or something like very high computationally, because ultimately it's their resources. So let's go. So prerequisites, so these are basically like labs that you have to do. Okay, lab fundamentals, it is explaining you the start lab, the credits that you need. We don't have to worry about the credits. Credits is very like for people who are like paying for it. Since we are enrolled in the program, we are getting a monthly subscription, so we are having a time bound thing. So you these are all available only till like December 14th, so that's why I'm like conducting them right now. uh, Paying for lab, I would strongly suggest not doing these to buy credits. We already have credits if you are enrolled into the program. So yeah, it is also to like make distinction that you're on the correct website, so you don't have to like pay them. So let's test our understanding. This builds a temporary environment in the Google Cloud. Start lab. When we press start lab, we have this environment. So yep, that is correct. Let's see. Okay, it is correct. When the timer reaches 000, you will lose access. Very true. Some labs have tracking, yes, which scores your completion, which is true. In order to receive completion credit for lab that is tracking, you must complete the required hands-on activities. True. Accessing the cloud console, we have started our lab. We have the details span. So this is the username that we'll use. This is the password that we'll use. This is the project ID. So this in Google, it's like very nice thing that you can like segregate all of your projects. So if you're running a website on this one, and if you wanted to run like a AI model or something, then you can use the next one. So you can use another sort of project, and they will be segregated from each other. This is the project ID that we need to work this all the tasks that you have to do. We have to do in currently this one. So your credentials will resemble the image, but not. Okay, so we these will be different, but this and this thing is the same. That's what you're trying to say. Username and password. Sign into your Google console. We've done this. Username, and then clicked on next. We have entered a password. We have agreed to the privacy policy and everything. So it's now asking which of the field is not found in the left pane. So I'll make it a bit interactive. Okay. So guys, which one of these is not here? Can you guys tell? Project ID is here, password is here, open Google console is here. So which one is not there? Yeah, system admin. So system admin is not there, so we'll correct it. Yes. The username in the left panel resembles cloud IAM identity. IAM means identity and access management. So we have this sort of thing, something something at quicklabs.net. So yes, this is true. So I'll mark it as true. Yes, correct. Project in the cloud console. Okay, so it's explain the project. If you wish to, you can read through this. Let's test your understanding. Okay, so now it's asking us the sort of questions on the project. So Google Cloud, um, an organizing entity for anything you build with. So organizing entity. So I will believe this is the Google Cloud project. Quick Labs resources. So if you can see, you can go to the all things, and here there's another project that is called Quick Labs resources. So in here there are a lot of resources that are pre-made, basically like libraries, but you can go through them and you can access each one of these. These are not editable, but you can you can actually like use them. Quick Labs resources. Let's go to our own one. Quick Labs resources is a shared read-only uh, for all Quick Labs users, which means you cannot delete it or modify it. That is true. We can only read them and like use Quick Labs resources, the project where you run all of your lab steps. True. No, it's false, 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 false. Sorry. Okay, navigation menu. So this thing we are going to talk about. Navigation menus and services. If the navigation menu isn't open, you can click through it and you will see all of the services, or if you wish to see even more, there are more below, and you can pin them basically. So if I wish to pin this one, it would be mentioned over here. Okay, navigation menu. So you can view all of these here. You can move more products over here. You scroll through, you can see that. Roles and permissions. So basically like permissions you can give if you have like several users working on same project. You can give them access. So you can say you have a friend, you wish to show them your project just to like monitor them, but you don't necessarily wish them to edit that. So you can give them permissions. So editing is the role is like editor, and the for viewing permissions you can give them the role of the viewer, and the owner is the one who like actually like made the project. All right. So now let's test our understanding. Offers quick access to the platform and also outlines its offerings. The navigation menu. Yes. Basic rules set project level permissions, and unless other specified, control access and management to all Google Cloud services. True, I believe. Yeah, true. Viewer permissions, permissions for actions, modify state such as existing resources. So that would be the editor rule. Very good. So now APIs and services. This is where we actually use the Cloud Console. These were all just like introductory. So here we'll use the service of API and services, and we need to head to library. So we'll use the Dialogflow API, which is actually used in like Google Assistant, basically like language processing. So, or no, it's not used for that. It's used for like chatbots actually. So yeah, for example, chatbots and voice-powered apps, etc. So we'll actually like enable this. Like Google has a pricing for it. So if you wish to like have use it for your website, for your app, you have to pay this much amount for how much time it is accessed. But we are we are using this for learning purposes. So this won't be applicable to us. This entire session, when you open up a lab and you end the lab, it will be discarded after your lab is done. So it's not permanent. And so yeah, we can go through this. So it says to enable the app. Let's enable the API. Click enable. Click the back button in your browser to verify now that it's enabled. Let's check. Let's reload. It is API is enabled. Let's see through the cloud dashboard. So here in API, if you go to API overview, so if you go to the API overview, we can check that cloud logging API is there. Let's filter it through the names. How many? Okay, Dialogflow API. This is the one. Let's see. Dialogflow API is working. So let's see. Go to API overview, and we can check whether like the API is working or not, or if we can check my progress. So this is very like interactive thing. So if you enabled it here, it can also check whether like you have enabled it or not. So if we go through this, yes, assessment is completed. Dialog flow API, here it is. Status is enabled. So we can check here as well, and here it will check our final thing. So it will go through like each lab will go through like this. There will be a set of tasks that you have to do, and it will in the real time it will check whether your assessment is like completed or not. Sometimes it may happen that you have done it, but like in the here the assessment is like not completed, so you can try it several times, or you can check where you have gone wrong. So that sort of like troubleshooting sort of attitude that you will build. So like, where have I gone wrong? Oh, okay, I exposed the wrong port, that's why it's not enabling. So that's very like, you can check here like 100 out of 100. So you can actually like end the lab now, and for us the lab is done. So okay, test our understanding. When you start a lab, you need to enable APIs in your project, start working with the Google Cloud. No, like APIs is like a optional thing. Okay, so no, I don't need to. Okay, yeah, cool. That was so silly. So now when you're done with the thing, if you see 100 out of 100, then you can end the lab, and that's it. Let's actually go through like a real lab. Let's go through actual Quest. So each Quest has a lot of labs. Let's go through this one. Create and manage cloud resources. It was very fundamental sort of Quest. So here we have to do first off a tour. Okay, we've done this. We've gone through this. We've done this now. Now creating a virtual machine is the like fundamental one, because like a lot of cloud computing engine, and so cloud gives you like a lot. Okay, so we are not able to access this. So since our lab is done, this account is like not been shut down, so we cannot access it. We'll have to make a new one. So I was about to like explain like virtual machines. So let's go through the slides here. Okay, so there is like a lot different types of services provided by the cloud. One is like IaaS, which is like infrastructure as a service. So you'll get like a virtual machine box, and it will be just like installed like a operating system. Most likely it is like Debian GNU/Linux. On top of that, you build upon your apps. Okay, your website, anything. On top of that, you build upon your web server, your API calling, or any sort of like database. You start from scratch essentially. So that is IaaS, compute engine. And app engine is like a platform as a service. So if you guys are into like web dev, if you guys are into like web dev, I believe like if you've used GitHub pages, so if you have like a HTML site and a bit of CSS, you can use the GitHub pages so to host your website. And so platform as a service, it is like an abstraction layer on top of infrastructure as a service. So you'll be given a platform, you just have to give your code, and you don't have to worry about the like setting up the infrastructure, everything. It is all taken care of by the platform as a service. So app engine, you just have to give your code and it will deploy it for you. Serverless cloud functions, basically it's like it does not require an entire server. The names sort of contradictory, like like serverless, it does not require a server. No, it does require a server, but it's just that it turns your code into a function basically. You can enter values and it will output you the values, pretty much like a server. It is like from Cloud Run and Google Kubernetes engine. Kubernetes is very interesting. If you guys are you guys aware about containers, Docker containers, or any? So compute engine lets you run virtual machines on Google infrastructure. So on our first quest, on our first lab, we'll be running a virtual machine. Let's go through that. Start lab. We'll do the same thing. It says here, use an incognito or private browser to run this lab. This prevents conflicts between your personal account and the student account, which may cause extra charges incurred to your personal account. All right, so let's split the screen, and here we'll see the how to create a virtual machine. And let's go below. Setup before you start the lab. Okay, same thing. Let's move on to the task itself, or let's sign in to the Google console. So first our username, let's enter our username properly, and then let's enter our password. This is a temporary account, and we are doing this on a temporary lab, which is only available for like 40 minutes, but I hope we can do this much in less time than that. So here it lays out all the instructions. So first we have to create a new instance from the Cloud console, and navigation menu, first we have to go to so this is basically how to set up a virtual machine using the Google Cloud dashboard. So this is you can do it this way, or you can also use the gcloud shell. We'll use that in the future lab, but let's use this. Okay, hello, yes, agree and continue. And let's go through a navigation in menu, and let's go to the compute engine VM instance, and let's create an instance. And so our instance name would be GCE lab. Okay, copy that, paste it here. Our region would be US West 1. I'll increase the size here. Our would be US West 1, US West A. So there is a region, and in region there are many sort of region is basically like a data center which you choose. So whenever you're setting up a server, make sure to choose the region that is like closest to you, so there's like less bandwidth requirements. Okay, region, and in region there is zones. So there is one region, and there may be many zones in that. So there is like 3 different like data centers where like Google's cloud servers are running. We are instructed to do choose this one because they are like, you know, expecting these ones. So if we choose like something else, and we try to, you know, do everything, they may not count our assessment point progress. So we have to choose E2 type thing. Okay, E2 type machine. E2 is like CPU based. E2 to vCPU. Okay, and boot disk. This is boot disk is like by default for 10 GB, and using Debian GNU/Linux 11, if that's working. And we need to allow firewall to accept allow HTTP traffic. So anyone on the internet can use the HTTP port, which is port 80, and HTTPS is for and firewall. So we need to allow for HTTP traffic to go through, and by this anyone on the internet can visit this sort of site. As if the ports are closed, you cannot visit the site. And HTTP traffic relies on port 80, and HTTPS relies on port 443. Those are the default ports. And let's set up the instance. So it will be notified to you when it is created. So let's wait for the time being. Create, and we'll use SSH. So SSH is a secure shell. You can log into your browser using secure shell. Here I think when it is like done. Okay, yeah, it is done here. So I'll actually make this full screen. Okay, so by SSH means secure shell. So we'll be logging into the instance with the use of command line. So it will open up a new browser tab, which is like SSH in browser. I usually use SSH in like the terminal base. So let's see SSH in browser. Okay, and now we need to install an Nginx web server. So Nginx, there are many kinds of Nginx you might have heard of, or Apache. If you are in CC, then later you will have to like have a project where you have to install like if in like AWT, that you may have to install a LAMP server. So that is like Linux, Apache, MySQL, and P is PHP. So Linux LAMP server or a WAMP server, Windows, Apache, MySQL, and PHP so that you can get like a front end of your MySQL database. So to update a browser on any or like Debian based Linux systems, you have to do sudo apt-get and update. So what apt-get update does is that if say like on your local machine you have a Python version of 2.1 something like that, and on the repository on the cloud there is the version 2.6 that is newly available, so it will sync up that, and to so that is done by sudo apt update, and by sudo apt upgrade you basically from Python 2.1 to Python 2.7 it will download and it will install the newer packages. So we'll just install nginx -y so that it doesn't ask us, it doesn't prompt us why, it just automatically it says yes. So ps is a process command, so we'll you see that if psu it will show all the processes running by user, and a and w and x, then it will show a lot of processes, a lot of processes. So from that we have to only check that whether nginx is running or not. So we'll do grep is for finally finding out from the all of the stuff, and then we'll do nginx. So now we can see that is nginx is running on root, nginx is running on this www data group, data user and student user. So no, student user, this is us, and we have even the process of grepping nginx is mentioned in the ps. So that's that. So expected output, yep, pretty much the same. So now we have an external IP attached to our instance. Let's go to our instance, and if we can see there is an external IP. Okay, so as you can see, like there is an external IP attached to this over here. Is that okay? This is internal IP. So internal IP is if you're within the network, you will be able to access it. External IP is for so anyone on the internet can access it. So if you guys go to this IP, then it would say that okay, nginx is running on our server. And if we disable nginx, this would not come up. I run my own my own web server on nginx as well. So like if you go to ssh sure, okay. So if we go and check, like if I'll open Firefox, I open so this is my own website. Now I'll disable it, systemctl stop nginx. So if I stop nginx, this website should not load, and see, it does not load. So that's basically what we did essentially. First we SSH'd into it, and then we installed nginx, and we could see that nginx is actually running. So if I now do systemctl start nginx, my website should be running. Yeah, it is running. So that's pretty sweet. Let's do next. What are the command tasks to do next? So let's check our project progress if the nginx server is running. It is running, we can see that, but let's check with the Google progress checker, and yes, it is working. So now we will use now we have set up an instant cloud compute engine via the dashboard, but now we'll use the gcloud. So we'll close this. We'll use the gcloud G shell to provision a VM. Let's see how that goes. So it will take some time. Gcloud command line guide. Let's see. It will take some time, and we have to click on continue, and then we have to authorize as well. It is a provisioning cloud shell machine, and that cloud shell machine is being connected to our shell instance. So let's see if we could do gcloud config from gcloud command line utility, which is available. We can make a compute instance, and we can give it the flag, so what is called, to create another compute instance. So let's check like all the VM instances that are running. Only one VM instance is running, that is GCE lab. Let's do full screen. Okay. So only one instance is running, that is GCE lab, And now we will create a second. Okay, GC lab 2, machine type E2, medium, zone, everything is the same. It's just that we are doing this on the shell instead of like clicking buttons and doing it through the console. Command line is like pretty good. Okay, now it is asking to authorize. Okay, so command line is pretty good in terms like if you want like more modularity, if you, because a lot of software, they are written first on the command line and then they are written for the application based, GUI based. So now we can see that a GCE lab 2 instance is like done. So if it is provisioned, so if we like click on reload, and here we should see GCE lab and then GCE lab 2. There we can see GCE lab and then GCE lab 2. And if we can check our progress, create new clouds instance, it's working. Create to see all the default, to see more options, basically you can click on that. So which of the following ways you can create a VM instance in Compute Engine? We can use the cloud compute as we have done in the previous task, and now we can also use gcloud, the command line tool, through G shell, Google shell. All right, so I guess we have done 100 out of 100, so pretty cool. End lab, yep, submit. These two are optional, so we can actually head on with the third lab, and then there is fourth lab, fifth lab, sixth lab. All right, so let's start the third lab of the first quest. So in this lab, we'll be getting started with the Cloud Shell and gcloud. So Cloud Shell is like a command line interface which you are provided by the Google SDK, and you can use it in within like Google Console as well. We'll be showing you it in a bit. All right, so we can see that the numbers match, ending with 926, ending with 926. So yes, this is the correct project we're working in. And like let's read out some of them. Cloud Shell is a Debian based virtual machine. So basically we're working, whenever we launch a Cloud Shell, when we read into it a bit, it is basically provisioning a cloud Debian machine, and then it is connecting that shell with our project. So let's see. So Cloud Shell comes with Cloud SDK, gcloud, Cloud Code, and an online code editor as well. So you get an IDE which is very similar looking to VS Code. Probably it's like open source version of it, but this is so you can get like an online code editor working within your browser. You can do that. You can click here, and you can use it to like run your apps within the cloud. But this is focused on the shell. So let's work with the shell provisioning. Our shell. Your cloud project in the session is set to, let's see if it is the same, 926, 926. Yes, it is the same. Cloud instance is set to our project ID. If we wish to change it, then we can do gcloud config set project and then project ID. Okay, so what we'll do, we'll practice gcloud commands and connect compute services hosted on Google Cloud, and prerequisites: familiarity with the Linux standard editors such as Vim, Emacs, or Nano. We don't really use Vim or any sort of text editor over here, but it is good to know. How to start your lab? Okay, we have already gone through all these. You must use the credentials from the left pane. Don't use your skill boost credentials because it will be then targeted to your account. We don't want that. Always use these credentials, this username and these credentials, and that's why you need to access to a standard internet browser. Chrome browser recommended. I'm using Chromium. Use an incognito or private tab window to run this lab. This may prevent conflicts between your personal account and the student account. Time to complete the lab. Okay, how much time do we have? We have 40 minutes. I hope we can do it in less time. It is connected. Yep, auth list, and it should look like. Let's try it out. Okay, so it will basically list out which of we authorize it. If we give it basically our permissions, like a sort of a pseudo privilege, so it will detail out all the accounts that are running. So this is the account that is running, and that is actually our account. So if we go and match the C26 and then add quick labs, and then we can see C26 26C at quicklabs.net, C2C quicklabs.net. So it is yes, it is accurate. If you wish to change the account name, then we can, but we already only have one account and it is properly configured, so we need not do that. So yes, our output did look like this, and if we do project ID, it will list out this number. Config gcloud config list project, and it will list out exactly this project is equal to quicklabs GCP 04 8B ending with 926, which is correct. After Cloud Shell is activated, you can use the command line to invoke Cloud SDK software development kit, gcloud tool, or any other tools. Later in the lab, you'll use your home directory, which is used in persistent disk storage to store files across projects. Your home directory is private to you and cannot be accessed by other users. This is a table showing the zones in the respective regions. If I'm not explained zones and regions properly, I'll show with this quick diagram. So firstly, there are these locations throughout the globe. There are like 130 plus locations by where location means like a actual like geographic area where Google Cloud Google hosts it with data centers for Google Cloud, and a region is like a specific geographical region and area, and inside one area there are multiple zones. So let's see, in each region there are like multiple zones represented as such. So London is the location, so Europe is the continent, and at the west location region comprises within and in Europe West 2 we can see that there are many zones, 2A, 2B, 2C. This is the normal nomenclature. Heading to this again, certain Google Cloud compute engine resources live in regions or zones. A region is a specific geographic location where you can run your resources. Each region has one or more zones. So whenever we are initiating a compute engine, we just gcloud shell, we have to mention the region specifically. Mention the zone. So a zone is enough, because a region, when you say that you wish to deploy it in a region, that is like an incomplete answer, right? Because once you specify region, then you also must specify the zone. So just by providing a zone like US West 1A would be enough, or if both the parameters are being asked, then you can just say US West 1 and then US West 1A. So it will be through or else we can set that sort of region up. So here we are using gcloud config. This gcloud config has a lot of flags, like these are called flags. When you do config flag and then do help, it would list out a lot of functions. So when you when you do help, it will be like this. You can use your arrow keys to read, or you can use Vim keys as well. You can use JN key to go down and up. So if we read about it, we can see there are a lot of commands. There's a get, so you can get values. So if we do gcloud get a project ID, we'll get this. List basically every project. So print the value of a certain property, list all of the properties, and set to set a property, and unset to remove that property. So we are going to set a property here, that is the compute region. So we can do config and then set and then compute region and then US West. So here we are using the Western US region, which has the name US West region, US West, and the zone would be US West 1 -A. So let's set the region US West 1, and it should give us a success, updated property, that is a success. And then if we do this get value of compute region, it should tell us US West 1. Let's see, yes, we got the value US West 1. And if we now set the zone as well, let's set the zone to US West 1A. So that sets the value, or the property has been updated successfully. And now if we do compute /zone, I believe we can get the correct answer, but let's see. Okay, yes, it is zone. And then we'll get US West 1A as the zone. So now let's find more information about a project. So if we do get value and our project's value, so we'll get our project's value. Since there's only one project, we are getting only one. It's very similar to the one we did before, config list, but it lists out every project. But we only have one project, so the values of both of them are the same. Quick Labs, GCP, 04 and ending with 926, and then GCP 04 ending with 926. In Cloud Shell, if you run the following gcloud command, we can give the details about the project. It would basically tell us, so here, this is basically a variable. So we set this value into a variable when we use a command. Then we need to specify some value over here. But instead of using the previous command, using the previous get value command, and then me copying this and then using this. Oh no, I have to copy two times. We paste this, we get a similar output. We paste this, then we'll get the entire all of the information from the current project. Its value, its zone is this, its region is this, the SSH keys it's being used. This is the public key. SSH RSA. RSA is like a cryptographic algorithm by which we can generate symmetric keys. And let's move ahead. Now we are setting environment variables. So environment variables, what is the difference between like environment variables and shell variables? So in shell, if you go like I'll demonstrate it right here. If you go to shell, like this is a shell, this is a bash shell. So if you want to echo, want to know which type of shell you're using, you can use $sign and then 0 symbol. So it is saying this shell is bash. And if I open a new shell, a new terminal, and I switch to another shell, which is like you can use sh. Okay, sh is bash. So we can switch to zsh, which is another shell, and mine has a different prompt as well. So if I do here the same command, echo 0. So it would say it is zsh. So it's saying bash here, it's saying zsh here. So these are completely different shells. I'll remove this here. So how to set a variable? You can set a variable just very simply like this. Let's say my age is 20. So I'll say, well, first do echo age. It just says age. If I do echo this $sign and then do age, it would print out an empty variable because age is not assigned to anything. If I do age is equals to 20, it has now set the 20 value to age. If we now echo age, it would obviously say age again. If we echo age with the $sign in front of it, making it a variable, and now we echo it, it would say 20. But this is a shell variable, it's not an environment variable. If we switch to zsh, and now if we do echo age, it would obviously say age, but if we do echo $sign age, it would say nothing. So to set up environment variable, we use the command export. So let's export age is equals to, just like say it's my birthday and it's 21 now. So export age is equals to 21. Alright, let's echo age now. Echo age, echo $sign age. So it is 21. If I go to zsh, what would be the, what would be output? Would it be 20? Would it be empty? Would it be 21? Let's see. Echo $sign age, and it's 21. So that's what environment variables mean. Regardless of the shells you're using, it is set globally. So that's what like environment variables mean. Let's set our project ID as a variable. So instead of typing this command again and again, because whenever you run a command each time, right, it uses some computational resources. But if you assign it to a variable, and if you just call that variable again and again, and if it's the same value, then it is better to store it in a variable. So we are now storing it in a environmental variable, and it would be project ID. And we'll also create an environmental variable to store our zone. So next time, whenever we are assigning a compute instance, we can just mention zone with the $sign in front of it. We can just echo the project ID and with $sign and project ID, and then zone with $sign and project sign. And this e variable e flag is set so it can distinguish the /n. Else, if you just use echo, then I think it would like also print the /n. So it is to make a distinguishing factor. It will read slashes, and if there is a like a n or t, something like that, then it would make white spaces or new lines in this case. So let's see. So we get project ID as Quick Labs GCP 04 ending with 926, and student zone as US Quest1, which is correct. So let's create a virtual machine with gcloud tool. Earlier we used compute engine, VM instance, and we clicked a bunch of buttons, and then as the result of that, used a drop-down menu. As a result of that, we created computing instance, and this is us doing the exact same thing, but through the terminal. So if we use this gcloud compute instances, create GCE lab 2, we do that. It will take some time, but if we go to our dashboard for compute engine VM instances, we can see that GCE lab 2 has been provisioned, and it is also running. So it is running, and the output should be the output should be created. Yes, it has created, and using the API, and its name, its zone, and its type, and its internal and external IP. Internal IP is for all the other machines, all the other servers that are in network with the VM instance, and external IP is for like if there is a port open, for example, if it's a web server, for example, like if it is a web server and it wishes to serve like a website on port 80 or port 443, then anyone on the internet can view this IP and then view the website. Gcloud Compute. Gcloud Compute allows you to manage your compute engine resources in a format that is simpler than the compute engine API, which I believe is this. Instance create a new instance. So basically, just breaking down the previous command to create, and then the instance name here, VM name, and then machine type of the machine, A2 medium, and zone, and then if you omit the zone, the Gcloud tool can infer your desired based on default properties. So the properties we set earlier over here when we get the set config set compute zone value, so it will be default by that. So let's check with the progress checker if we have completed our task or not. We have completed our task. So yes, so if you click on this, create help, I think we have already done this as well. So we can see all the other commands and flags. So it is there are a lot of flags here. So these are two dashes are called flags, and there is examples. Yes, see, these are the flags. There are a lot of flags here. Too much for me to even explain, but you can set almost every property, every parameter by using these flags. So what should be the disk size, and like by default, by default the boot test size is 10 GB, boot test type, and then you can use other ones like boot test type lists, so we can check the actual value that can accept and so on. So we have completed our lab essentially. Our next lab is revolving around Google Kubernetes engine. So it's important to understand what Kubernetes actually is. So before understanding Kubernetes, you also need to understand what containers is. So containers are like basically whenever we are like developing an application, it requires a lot of dependencies. It may require a certain like a version of a language. It may require a library. It may require any binary, any ecosystem of a base image. So if it runs only on say certain operating system environments, so most popular is like Ubuntu. So there are like Docker images, like containers of like actual like Ubuntu operating system. So you can, if your application works on that, so you can bundle all of the dependencies together and make a container, and that container can then be shipped to other people. So why do we actually need this? Because of the problem of if you developer software, if you write a code and that code, say for example, it only works with Python 2.7, right? You have the latest and greatest, and it has some more features than the previous version. So Python 2.7, okay. I'm guessing like Python version 3 has also rolled out, but say for this example Python 2.7, it runs on Python 2.7, and you give it to your friend, and your friend, he has some older system, it only has like Python 2.1, so on his system it does not really work. So by the use of containers, you can bundle your Python 2.7 dependencies, all the libraries, and the entire ecosystem in which your exact code it can run, and you can make a Docker image out of it, and you can then send it to your friend, and then your friend will be able to run your code or your software. But the thing is, this concept is very brilliant, and a lot of companies, even Google, they use this a lot, and they use it to such extent that they use containers at a very huge scale. So huge at such huge scales, there also need to be like an orchestrator. So if you have seen an orchestra, like and if you go to any like picture, there are like several people over here, but there is one orchestrator here. Okay, so if I open this image, there are several people over here, so they can be thought of as like individual containers, and to control all of them, there is a single orchestrator. So Kubernetes works in such a way where it acts as this container orchestrator. There are like very many different types of. I forgot to tell you, there are like many different types of containers, but the most dominant type of this container is Docker. I think I've also heard like Red Hat alternative, that is a Podman, and and Kubernetes usually has Docker running in its individual pods. So let me see. So Kubernetes handles all of these: scheduling, lifecycle scaling, naming, load balancing, storage volumes, logging, monitoring, debugging, introspection, identity and authorization. It does a lot of things. JKE, Google Kubernetes Engine, is managed environment for deploying containerized apps. So all of these services by Google, which are like Gmail, Google Gmail, I believe, and Gmail, YouTube, and their web search engine, they all run on Kubernetes. It's a very highly used thing. And so if we see IaaS, PaaS, so this is like a hybrid infrastructure where cluster manager and orchestration engine built on Google's container experience. So okay, so that's it. Everything. Let's actually like jump into the Quest, the lab, and I hope that explanation was fair. The GKE provides a managed environment for deploying, managing, and scaling your containerized application. So we may have a containerized application, and we can scale it. So say if only like 10 people are viewing it on your server, or if say 10,000 people are viewing it, it should scale accordingly. The traffic should not hinder your availability of your website. So we would be using another account, and another account I'd use student name as this, password as this, and project ID should match. Let's see if our project ID matches. It ends with FD7, 6FD7. You see that our project ID as well. it matches, and it is 6FD7. Let's begin. So Kubernetes has a lot of provides a lot of features. Here it is load balancing, node pools. So I wish to like explain. I thought there was like a explanation, like a architecture of Kubernetes in this slide, but I probably forgot. Kubernetes architecture. Let's see. So it has two major. So this is Kubernetes master. Here it has written master node, but I believe it's called the control node. And these are little pods, worker nodes. So these worker nodes, they expand, and they they can scale up horizontally or scale down depending upon the traffic and depending upon the user interface. The user interface may be like a GUI sort of thing, and kubectl is the CLI version of it. So I personally have a kubectl here as well. So but I don't use Kubernetes. Kubernetes is very overkill if you're on like a desktop. If you're using it on a server, which is like accessed by thousands of people, then Kubernetes is a must to have. So it includes an API server, scheduler, does all of these features, controller manager. etcd is it's like a database, I believe. It's for security purpose. It was stored in the master and not in the worker nodes. So by design, if you can see this, the worker nodes are the website. So the external world only interacts with the worker nodes. They never interact with the master. The master is only accessed by the person who is controlling it. So if you can see it here, yeah. So the master is only controlled by the developer of the operator, and the users are then actually redirected to the Kubernetes nodes. No, they are like not redirected, but they're like if this node is like very overworked, then this node will be the one who will provide the service. And so it's very secure sort of architecture. etcd, it is not touched anywhere. It has for security reasons, and this is very secure architecture. Instead of like you having like a means server, and you are exposing the actual application to the users, which can allow all sorts of vulnerabilities associated with it. So let's head on with our project, head on with the lab. These are the basics. Skim through them. We go to Google Auth List. Default compute zone. Okay, we are using Cloud Shell again this time. Or continue provisioning our Cloud Shell machine, and then that shell machine will be connecting to our instance, to our project. That Cloud Shell instance will be connecting to our project. We'll set the default computing region, which is US Central 1, and default computing zone as US Central 1B. Okay, then we can see that it's a success as well. Create a cluster with the name of lab cluster. And creating a Kubernetes cluster would take a lot of time, so you need to be patient. I believe, I guess, like it will take a lot of time to create a JKE cluster. So if your lab is like if the time is very less, so I'd suggest to end the lab and do it again, rather than if waiting for this to be done, and then your entire lab closes because of their time limit. All right, so our cluster has been created. It took a long time, and we can see the output name is equals to lab cluster, US location central 1B, and master version. Yes, the status is running. So number of nodes, that the worker nodes that I mentioned earlier, and those are 3. The load will be balanced among 3 nodes. So create a JKE Google Cloud Engine cluster. So yes, our assessment has been completed. We are there about 1/4 the way. We have just only created a Kubernetes cluster, like get the credentials. Okay, so now the kube config, whenever we run kubectl, it will only use whenever we do any sort of kubectl or kubectl, some people say, whenever we do any sort of commands involving that, we will be only working on the lab cluster named Kubernetes. Deploy an application to the cluster. So we'll be deploying an hello server. So basically it's a very simple web server which just says hello world. So when we do kubectl create, we were using the create command, kubectl create. So if we do kube deployment flag here, so if you place that, create deployment, and hello server would be the name of the server, from the hello app container image. So its name is hello server, but we're using this image, hello app. So the Docker image I was talking about earlier. So this is the containerized image here. And if we do enter, then this it should deploy very quickly, just like that. Because the time Kubernetes took to set up the cluster, it is now compensated in this very fast deployment, and sort of updating the Kubernetes is very easy. Now we'll expose the port 8080 for HTTP, and it would now we'll make a service, and we'll expose the port on 8080, and we'll use it as a load balancer. So the traffic or the sort of computing thing will be distributed towards the 3 node. You should see the expected output. Get service, let's do that. Yeah, that should work. So we'll see hello server is the service, and Kubernetes cluster is working on 443 for 5 minutes now, and hello server, we've just launched this, and that cluster IP is 8080 and GCCP. Okay, so we are now waiting to get an external IP. So now we have external IP. We can see that the actual Kubernetes cluster, it does not have an external IP. It is not exposed to the internet. Only the node or the function is exposed. So let's copy the external IP, and if we go to this IP, it will redirect to the website which is running the hello app, and that is like hello app is just a website that says hello world. So let's see. It might take a minute for the external IP. Okay, we have external IP. So if we do that, and to the port that we have opened, which is 8080, let's see the website, hello world, version 1.00, hello server. So very easy. Expedite output, the browser tab, it displays the message hello world exactly, as well as the version and hostname. Very cool. Create a Kubernetes service. Complete. Deleting the cluster. Deleting, I guess, would take a lot of time. Well, yes. So let's wait. Okay, so finally the cluster has been deleted. Took a long time as well. Promoted by, so let's check our progress. And done. So we have also, so in this lab we have created a cluster, deployed a container on it, which is like highly accessible, and then we have also deleted that cluster. Let's end our lab. Okay, we're up. Welcome everyone. My name is Somit Dineshan, studying in third year IT department, being your cloud GCCP facilitator, and also the cloud lead of GDSC SMIT. Fifth lab, I believe. Today we are going to like continue on the Quest1. So first of all, open an incognito tab at this point, and working on courses 2 and 3. If you have not, please do learn the fundamentals. These are essential, and the cloud infrastructure, scaling and automation, Kubernetes, these would also be very beneficial. Logging and monitoring would be, I believe, and infrastructure ones would be helpful in these quests, and terraforming would be terraform technology would be learning about it would be beneficial in understanding this quest. Regardless, I'll be guiding you throughout all of the quests. Let's begin. So I'll have to sign in first, so give me a second. All right, I've signed in incognito mode, and then you have to sign in to your Google Skill Boost account, and then we have done first lab, second lab. This is optional. You can do this or this one. Third lab, and then fourth lab, and then fifth lab, which we're going to do now. So let's start the lab. So this lab is about setting up networking and HTTP load balances. So in the previous lab, we have seen Kubernetes, which is this awesome technology where you can, scale horizontally very efficiently with the help of like containers, the pods that there are running Docker, and that is an incredibly like new on technology. It all functions on Kubernetes. But what would people do to have like a very high availability site before Kubernetes? So they would be using load balancers before that. So now differences between network load balancer and HTTP load balancer. Okay. Basically what we would be doing is we would be making 3 instances of a compute engine, and we would be distributing the load with the help of a load balancer amongst those 3. So say one compute instance can take about a traffic of say 100 users, but you are expecting about like 200 users or 250 users. So we can set up 3 instances. So our max capacity would be 300, and if say 100 are so it would be equally divided. So if there are say 2 compute instances, then network load balancer would divide the load by 50-50. If there are 3, then 33 like that. We'd open our Google console as always, open Google console, and I'd suggest it to run it in like a separate window over here, and copy your username and paste it. By automatically, if you're running this in incognito, then it works that way. But let's see. And then our password. So this is a temporary instance as always. So we're logging in, and if you agree to the privacy policy in terms and service, then go ahead, and then do match the GCP project ID. So this ends with AD1A, and let's see what this ends with. Okay, this one also ends with AD1A. So yes, that is this is the correct project. We can operate our work on this, and it would be reflected in the sort of checkpoints, check my progress. So we would open up cloud. We would be using Cloud Shell here. Cloud Shell is like very efficient, as we've seen in the previous labs. That in order to make a compute engine, we would have to go to VM instances, click a few buttons, and then we would initiate a virtual machine. But we've also seen in the same lab how to do the same thing. Like we have made a GCE lab with the use of this compute engine API. So basically, when we are clicking on this, it works with the Cloud SDK API, and then makes the virtual machine. Under the hood, it's doing the same thing as we would be doing on a CLI. CLI is a very important tool to learn. Just learning the console would do you great, obviously, but most apps, when they are being formed, they are first presented in the way of CLI, and then we create this sort of like abstraction layer on top of them in the form of application. So it's very important to learn CLI, and also like CLI is very modular. Say like in this project, we are going to make 3 instances. So with the help of CLI, we just have to put 3 commands. That's all. But with the help of compute engine, we would have to like click a lot of VM, click a lot of buttons, manage a lot of configurations if it's not very far off from the default ones, and so on. So let's auth list it. So authorize. So let's set up our compute zone, and also the compute region. So by default, if we make any instance, it would be within this region, within this zone, because zone is a subset of region. Then we have to create okay, let's read through this actually. So we have to create multiple web server instances. So this is very simple. You can read through this. We have to create 3 web instances, ww1, ww2, and ww3, and we can, like, it's very easy to read. We're using the gcloud again, using the compute 16 instances and creating it. Zone and then we only mention zone because zone is very specific, region is not really needed. Tags, we would be using this tag later. So basically all of these three, they share the same tag. So if we work say something on a sort of process to run on the three of them, then we could just mention this tag and it would do it. Machine type, E2 small, image family, GNU/Linux, Debian project, and then metadata startup script. So basically this is like a startup script. So when the instance is after it has been installed, the operating system, then it will run three commands: apt update the packages, and apt get install to install Apache. So Apache is this web server, very well known. If you are in the CSA department, you would be having like LAMP server in your like third year. So LAMP basically stands for Linux, Apache, MySQL, and PHP. If you're like AWT, that's what I've heard from friends. And service Apache 2 restart. So basically we're starting up the Apache server, and the echo command will basically put this in, and T command will write it in this file. So this is displaying header 3 HTML, basically very basic, web server www1. So basically when we run this server, and when we would be going to its external IP, internal IP meaning if you're connected in the network then you can see it. External IP means if we go on our browser and we can actually see it, then it would display this. If we go to this one, it would display www2, web server www2, then web server www3. So let's create these instances. The massive difference between Kubernetes and deploying compute engines is that Kubernetes takes a lot of time to just get started, whereas this instance would take a couple of seconds. As you can see, it is running. We get its external IP and internal IP. Let's do the second one as well, and we can do the third. We can copy the third one, and we'll create a firewall rule. So basically whenever we create a compute instance, a very few amount of ports are open, and we will allow port 80, TCP 80, which is the default port for HTTP protocol. Basically we would be allowing our users to see the contents of the web server list, the instances. Confused? Okay, so we've set up the three instances: www1, www2, www3. Very good. And now we would be setting up the firewall rule, but let's see what happens if we don't do that. So list out the instances. Let's go to this external IP. It will copy it by default if you just select it. Let's go to this 7. It would display nothing. It would probably even display like does not exist. Or it would just load indefinitely. Okay, like it should be very fast when you put an IP, okay, so basically we'll create a firewall rule with the name of firewall network LB, and this would say the target tags network LB tag. So LB standing for load balancer, obviously, and so all of these tags, tagged ones, will allow the port TCP 80. So when we do that, it would create. I'll close this one for the time being. Okay, so disabled false, so it is enabled basically. So let's go to any of this. Let's go to the first one, www1. So it will show web server www1, and this one should show, like, I'll copy it, copy paste, and copy paste. And so if we go to this one, it says web server www1 and heading 3 format www2 and www3. So these are our three low instances, basically web server instances, and we would be now so basically to view this in the command line itself, to basically fetch the source code of the site, we can use curl command. We can use certain flags as well, but just using the regular curl works. Okay, curl, and then and then it says heading 3 web server www1. Very good. Now we would actually then make a load balancer. Okay, let's check our progress. We would make a load balancer, and then we would be curling the output of the load balancer, and it would actually like go between the three of these. So it will show www1, www2, www3. Very let's I don't want to give spoilers. Let's go about it. So we'll create our IP, external IP for static external IP for our load balancer. So let's go ahead. gcloud addresses. So we need to create an address for this, because for a server by default it has an address, but for the load balancer we have to create an address. And let's legacy, okay, health check, basically health check, and then we'll create a pool. And so all the www pool, and in the pool we'll include the three web server instances. Let's add the instances. By this I believe we can just use the tags as well, but this is very sort of we can understand with the help of this instances www1, www2, www3. But if you have to do like a 50 of them, then it would be a massive pain. Okay, so add a forwarding rule. So adding a forwarding rule, so it would open up port on like 80 and address network LB IP1, which we created here, network LB IP1, and target pool www pool. Okay, load balancing is done. Now we'll send traffic to the sites. So this would be interesting to view the IP. Okay, let's view the IP of our load balancer itself. Okay, so this is the IP of our load balancer. Can we go to the site? We go to the site, we get www1, but if I refresh, I'm not really most probably it won't if he refreshes again and again. Okay, there's not much traffic, but if there were a lot of traffic, then it would roam between www2 and 3 as well. Let's do it on the shell, because on the shell we can refresh basically much faster. So let's okay, so basically doing the exact same thing. This gives us a lot, but we only want the IP address. So how do we do that in the terminal? Very awesome. So we use this command, and as it can say, it will give it in the format of JSON, and we will use JQ here. JQ is like a command line JSON parser. So if we use JQ, and then okay, let's actually read through it. So JQ, and then we can, it's very much like how you deal with objects in Python or something, or language. So IP address, if I do IP, let's say IP protocol, I'll do IP protocol. Okay, I forgot to write JQ itself. JQ and IP protocol. So it will just display me this this value TCP in like double quotes. But we don't want TCP, we want the IP address, right? So I'll just write IP address here, IP address, and it will display us the IP address. But we don't, and we wish to use this IP address, right, in future. So we want to store it, but we don't necessarily want the double quotes. So double quotes are there so that you can include spaces and all. So I don't want double quotes, so I'll just use the flag R. And let's see. Okay, now we get a very clean output, 3 4 something. Oh, I closed the tab, but I hope it was that. And now we'll store it in a variable. So for storing it in a variable, we'll encompass this in brackets. Please work. Okay, brackets, and we'll do a dollar symbol. So basically dollar symbol indicates that the output of this command, and to be stored we'll use equal sign, and then basically I just wrote this exact command. So, and we'll store it in the variable IP address. Okay, let's do this. So if I now echo the variable IP address, it would give me the outputs of IP address. Okay, let's now we'll run a while loop, and it will curl -m1 the IP address, and then done. So basically a while loop, it will run, I don't know how much time, it will probably run like a lot. Like let's do like a simple while loop, do do like say I. Let's do an iteration. I'll literally stop this in like 1 second, and is equals to, and then I think we do no, okay, yeah, do echo I is equal, and then we'll do I is equals to I plus 1 basically, but this doesn't really work in shell, so we have to use this to basically tell it that this is a arithmetic operation. And I'll close it. Oh no, close. Okay, yeah, we gave it the signal interrupt, but in just those seconds it incremented the value of I to 95911. Always be careful with while loops. I used it 9 times, but so this much time it took just to iterate. With curl command it would be much more, so we can use the while loop a lot by just curling. And when I refreshed the page, it usually showed ww1, but here we would see all of the three. Let's see. Okay, ww3, ww1, 3, 2, 3, 1, 2, 3. So you can see it as balancing the load across all of the three web instances. Really cool. Let's create an HTTP load balancer now. So we've made a network load balancer right now, load balancing service, and now we are building an HTTP load balancer. Let's make this. So first we need to create a template, compute instances template, create a load balancer backend template. So we are just going to refer to this template from now on. You can read, it's basically the same except few changes like these ones. A2L default SSL. SSL is like a protocol for secure socket layer. So HTTPS and metadata flavor, Google compute instances name. Okay, so we'll take the host name as well, and a host name from another, and page from this host name. Okay, cool. Okay, and then let's create a managed instance group. Let's allow health checkup. Ingress rule allows, okay, so ingress rule. So from this sources to this sources, it allows all the sources. So I believe like this is the allowed IP range for Google, like Google Cloud, all the servers that belong in the thing. Okay, this allows the and what else? Okay, now we have to create a static IP for the HTTP load balancer, and the IP was reserved. That was reserved. Okay, so now we will actually output the IP, not the IP that was. Okay, so I'll literally just put this in a variable IP adder is equals to, okay, echo IP adder. I don't want to write a pen and paper. Okay, so yeah, we have noted our IPv4 address, and now let's create a health check for the load balancer. Okay, it is done. Let's create a backend service for this, which has the protocol HTTP, port name HTTP, health check which we made before, HTTP basic check. So what we're doing here was basically making the health check thing, and health check here, allow health check. Okay, and here we created the health check, and here we are using this created health check, and add your instance as a backend to the backend service. So you use this command. Okay, and then we create a URL map. So we have to do basically three things. First, we create a template, and then we use a health check, and then we create a backend service, and we add the backend service to the instance group, and then we create a URL map. Okay, so we have created a added backend service. Now we'll create a URL map, and we'll create a HTTP target proxy. So we'll create this HTTP target proxy, and then we'll use this target proxy here in forwarding rule. Okay, no, it's better here. Forwarding rule, and then let's see if we have created the HTTP load balancer. Yes, we have completed. So let's try testing the. So we can go and check it in the navigation menu itself. Navigation menu, network services. Okay, our basic data is done from done here. Our lab is done 100 out of 100, but we're just checking. Let's just check it. Took a few minutes. You can skip to this part if you are like very confident, but load balancing. Let's check if it is running or not, if you've completed. Because in the next lab we would be also making we'll be essentially doing every single lab we've done, but the values will be changed. And so this is our load balancer, web map, HTTP. Now this is not. This is our this is our HTTP load balancer, and this is our pool, network pool, and this is the pool we've already created, I believe. And then we just added the backend service to this. And in the backend section, if it is healthy, yes, all backend services are healthy. They are not healthy, take a few minutes. When the VMs are healthy, as the load balancer using web browser by going to the IP address. So let's check if we can go to the IP address of this. Let's click here. If we go to here, okay, nice. So page from LB backend group 89 something. So page so yes, we have successfully created a HTTP load balancer, which is really cool. Okay, nice. So let's end our lab. We've done it very quick. Okay, 1 hour, so half an hour. Okay. Let's do a final lab. Final lab is a challenge lab, so it is, as it says, it is quite challenging. Let's see, because it's not simple copy paste. If you try to do a speedrun of this, it won't really happen, and I won't be explaining much here because it is basically taking inspiration from every past lab we've done. So it says some rules here, of what values to choose. If you're even naming an instance, it should be this one because it will be just focusing. It will be just scanning this name, Okay, hey there everyone. Bit of change in environment. I was actually traveling and I reached home. So now I'm recording from home and let's continue where we left off. So we were on the first quest and the task 3 was kind of on the last challenge lab. And on the last task, we were having a bit of challenges. I've like written it down in like a notepad, like because it required a bit of special attention. So I will just skim through by completing task 1 and task 2, and let's head on with the third one. I'll pause it for a bit, jump step, or maybe not, I'll just speed this up. So I have start lab, open console, another window, copy this, paste this, next, paste this, understand. Okay, I'll multitask the Kubernetes and HTTP load balance together. Okay, so we've done this, and it takes a lot of time to make a cluster, so I'll just make a new tab. So startup script, we need to run this, and then I have all these 8 bullet points. I have written them in like a text file, so it's called template. So here it is. So template. So first we need to create an instance template. My instance template's name is a web server template, and these are the flags. You can refer to them in the lab or like in the docs. Now we need to do the second thing, which is the target pool. So here basically, okay, I'll explain it. So we need to make 2 Nginx server which attacks the instances of a group, and that group will be load balance. The load will be distributed like 50-50 among the two. So this is the startup script. So after deploying the instance, it will first update the packages, install Nginx, which is a web server, and it will start the web server service. And then sed is like a replacement tool. So we'll s substitute, and then we use slashes to indicate particular term. So this is the Nginx. The Nginx keyword will be replaced by this Google Cloud Platform. This is the file that will be where this activity would take place. And EOF means end of file. Put entire of this in startup product, so we can cat out the contents message and read. It would be the same as this. Yes. Keep this in mind. Then you are only allowed to do 2 instances, as you might get banned. So to check how many computer instances you have, use this command. Gcloud compute instances list, and now we currently have none, so it should show nothing. Listed 0 items. So we need to create only 2 Nginx servers, not more than that. So let's go. I'll keep the objective here, and it does take some time. Notice that when you're done with it, it would not be filtered instantly. Then we can begin to create an instance template. Copy this. Done. I've created a template. If you wish to see that template, you can go to VM instances, instance templates, and here we have web server template was the name. Create web server template. Now we'll create a target pool. So target pool, and the name of that target pool is Nginx pool. Manage the instance group. So we need the third objective, managing the instance group, and it is basically provisioning 2 of these instances. So web server 1 and web server 2. That is the base name of 2 Nginx servers. So this, and we'll mention the target pool. Here we the web servers. Same result would be with this command, and these are run. So now we'll create a firewall name, and here we have to make sure that we name it correctly. So we need to copy this and please replace it here. Created. Now we will
create a health check, and then we will assign the health check HTTP basic health check over here to the backend service. So right now, with this command, we'll be creating the manage instances group, name the port, which is port 80. I got it. What's this? Now creating the backend service, and then in the next command, we'll attach these two. Now we'll create a URL map, and then target the HTTP proxy to route all the requests to the URL map. Then a forwarding rule, and to view the rule we just created, we'll use this command. And our rules here. So we should see the website behind the HTTP load balancer in some time. This is the IP. Let's see. It does take time, so I'll do the other ones that are remaining. Finally, the load balance forward. Hang on, it is correct. Okay, load balance is working. I'll make a while loop for it to code. Do no for I and for also do call one. Okay, so it's changing between ww8n and WNZ. Perfect.